Hello, participants. As we all know that we were progressing to on testing of hypothesis or significance testing. Earlier to that session, we have already completed one sample test, uh, and after that we have completed the two sample tests. And remember, we were concentrating upon the parametric test. Parametric test means which requires the normality assumptions for the population. So accordingly, we have done one sample t-test, and after that we did two sample t-tests, and there were two. One was independent sample t-test, and after that we are moving to um, uh, the two sample related sample test. So today we will be progressing further, and now we will be considering the situation when the number of samples or the number of groups are more than two. And here we are concentrating, or we are mainly concerned about when more than two groups are independent in nature. And um, this is the concept that we are going to take up. And if we relate to that case, that was the Ventura sales reporting case that we have already done, right? So let me connect with that case so that you people have some idea about that. So remember, in this case, as we were examining the sales of the outlet of the different quarters, so in that case, we have already examined whether there is significant difference between types of outlet, means between rural outlets and the urban outlet. Now, obviously, one more question arises, that whether the different regions, they are four in numbers, have significantly same sales or significantly different sales. So now we are covering that part only. And for that, let us discuss a new technique that is known as analysis of variance of one-way ANOVA. Right? So for that, we are going for the PPT or the notes. Right? So we are still with the significance testing, and today we will be examining significance difference, examining the significance difference between means of more than two independent groups or samples. Okay. And for that, we are introducing a new technique that is known as analysis of variance. And in short, we will be saying this as ANOVA. Right? And first, we will do one-way ANOVA. I will be explaining what do we mean by one-way ANOVA. And after that, we will be progressing forward. Right? So just to connect with you, this is again a parametric testing. Parametric testing means there must be certain assumptions related to population or populations from where sample or samples are drawn. And here the assumption is that the parent population or population follow normal distribution. Okay. So this is a situation that we are examining whether there is significant difference between the sales of four locations. So since H naught proposes null difference, so we are taking the null hypothesis as average sale of the northern region equals to average sale of the eastern region is equal to average sale of the western region equals to the average sale of the southern region. So as you see here, we have number of independent samples are more than two. Here, four the number of samples are exactly 4. So we are examining. Now, for H1, since H1 is opposite to the null hypothesis, opposite doesn't mean that all must be unequal. Means it is not necessary that the mu n is not equals to mu e is equal to not equals to mu w is not equals to mu s. Means it is not necessary that all would be different. It may be possible that two are same, two are different. It may be possible that all four are different. It may be possible that three are same and one is different, right? So accordingly, we will say that all mu's are not same, or we say that at least one mu I is different from other. And since this is a parametric test and this ANOVA requires certain assumptions. The first assumption is population from where sample has been drawn should follow normal distribution. This is the first assumption. The second assumption is sample has been drawn randomly and independently. That's why this is known as K-independent sample test. So the samples must be independent. And another assumption is each group should have common variance or homoscedastic assumption is there. Now, a very basic question arises since this is a testing of mean. And as you see the hypothesis, this is testing of mean. But why we say that this is an ANOVA? So this is an obvious question that arises that why we say why there is dichotomy, right? Why we are performing testing of mean, but we are putting the name analysis of variance. So here I will be explaining the concept that why it is happening so. So for that, okay, right? Okay. So here I will be explaining the concept or the conceptualization for ANOVA. So here, let me show you the data sheet. So this is the data sheet. Suppose we are examining sales for the third quarter. So this is the data sheet where we have this variable that is the sales of the third quarter. So if you look for the data, which is at present visible to you up to the page length, and you see the values like 62, 53, 69, 77, 63, 61, and so on. So you see that there is a values are different. So we can say that there is variation inside variation in the data or variation in the sale. As we always know that there are two inherent characteristics of any data set. One is data must be similar in some aspect. That is known as the similarity aspect or the general tendency or the central tendency. The other thing is there must this data must be dissimilar also with some aspects, right? Means along with the similarity, dissimilarity should also be there. Otherwise, the data would be a clone only. Right? So this dissimilarity is being expressed as variation, sum of square, or dispersion. So this is an inherent characteristics of any data set. So as we look for any of the sales, we find that there is a variation. Okay. Now, this variation is known as total variation or total sum of square. Okay. Now, the next thing is now we will be examining why there is variation. Suppose if we look for these two cases, case number 2 and case number 3. So if we look for these two cases, this case number 2 belongs to the location 2, that is the eastern region outlet, and case number 3 belongs to the location 1, that is the northern region outlet. And if we look for any sale, suppose we are looking for Q3 sale, one value is 53 and another value is 69, right? This variation, so if we think about this variation, we say that this variation is because of the different locations or because of different regions, right? So this is known as between group or between region variation. Okay, this is one cause. Now, Instead of this, if we look for the case number 1 and case number 2, both are having location 2, both are eastern region sale, but their sales are different. Now we will think about it, why there is a difference. So we will say that this is because of some other reason, and this type of variation is known as within group or within region variation. So here we bifurcate our total variation into two parts. One is between group and another is within group. So we will be extending this concept here. Right? So as we have just observed that there is variation in the data set. Right? So this is known as total variation. And if we look for the reason, one is between group, like here, the groups are regions or the location. And another is within group, right? Variation. Right? So these are the two reasons between group and within group. Right? Remember our hypothesis was mu1 equals to mu2 equals to mu3 and so on. Here we are considering the general discussion, right? Otherwise, in this case, this is mu n is equal to mu s is equal to mu and so on. So this is the total variation present, right? Now suppose between group variation is high, right? So obviously within group variation would be low. So we can say that the sales of the different regions are different. Since sales are different, so we say that their means are different. Their means are different. Okay, right? Because between group means one region is giving or one location is giving higher amount of sale and another location is giving relatively lower amount of sale. Since one group is giving higher amount of sale, it means the mean would be high as compared to other one. So this is say that means are different. Okay, right? So if means are different, then obviously we say that there is a significant difference among group means. Now, now we will be converting this variation or this relative comparison into a statistics that is known as F statistic, which is the ratio of between group variation and within group variation. So if we go with the earlier concept that when the between group variation is much higher as compared to the within group variation, so obviously this value of F would be much greater than 1. Okay. And this F is being calculated from the sample. So this is known as sample statistic. As we all know that all sample statistic has a distribution that is known as sampling distribution, right? So this sampling distribution is the distribution for the F curve, and this is its approximate shape. Right? So this is 0. Its mode or modal value would be around 1, and this is a high value. Now suppose F is very large. F is very large means F is much greater than 1. Since F is much greater than 1, so it will lie on the extreme right side. And if we consider this area or the probability under the curve, and this area of probability is being expressed as P value. Right? So if this is the case, then we can say that this P value or significance F would be low because we have low probability or low area. So if this P value or significance F is less than 0.05, which is our default level of significance, then we reject H. Okay, so as you see here we have discussed the variation, but through that we have established whether there is a significant difference among mean or not. Instead of this, if between group variation is not much higher, it is approximately equals to the within group variation, then the value of f would be around 1, and the corresponding p-value would be high. That would be greater than 0.05. So we are not rejecting that. So we can say that there is an insignificant difference. Right? So this bifurcation is known as ANOVA or analysis of variation. This is known as ANOVA. Now the second question arises, why we say one-way ANOVA? Because here we examine the cause of variation because of only one thing, that is location. Since here the bifurcation or the classification is as per only one factor, so this is known as one-way ANOVA. If we have more than one factor, that is known as two-way ANOVA and so on. Right? So these two words are clear, why ANOVA and why one-way ANOVA. Now actually when we perform this test, right, then instead of this, we actually have, we, since as you know the formula for the variation is 1 upon n minus 1 sigma xi minus x bar whole square, right? So if we discuss this formula, this part is known as sum of square, and this is known as degrees of freedom. And it is approximately being termed as mean sum of square. Okay, so now we will be discussing this. Now this summation xi minus x bar whole square, right? This is the total variation, right? And for the time being, we will take this as double x bar, right? And this is a total variation. Suppose we have k classes. So this is I from 1 to k and j from 1 to ni. And here we will have xij and xi x double bar, which is the total mean. Now we can divide, we can always introduce a term that is I from 1 to k, j from 1 to ni. We have xij minus xi dot bar, which is the mean of a particular group, plus xi dot bar minus x double dot, yeah, x double dot bar square. So here we have introduced xi dot bar minus and plus. This xi dot bar is the mean of a particular group, particular sample, that is I. Now, if we open this, so we will be having xij minus xi bar plus double summation xi bar minus x double bar square. And the cross product term would be 0, right? So now if we write this part first, so we will be having I from 1 to k ni, because j varies from 1 to ni, xi dot bar minus x double dot bar whole square plus this double summation xij minus xi dot bar whole square. So this is known as between group sum of square, and this is the error term also known as within group sum of square. So we can say the total sum of square is being divided into two parts. One is the between group sum of square and another is within group sum of square. Okay. So that's why this is the name, that is the ANOVA. Now the second, right? And there is one more question arises. Sometimes we may say why we can't perform a number of t-tests by taking two independent samples, and through that we can establish that these groups are different or not. Obviously, that can be done. It would be computationally expensive, but with the software, the computational expensiveness doesn't hold that. But what is the reason? Since here, like we have four groups. So if we compare all, so we will be having 4 C2 combination, means it would be 6 comparisons would be there. And as we know that the number of times we apply the t-test or any test, there will be an error. Suppose this error is around 5%. So if we apply this from 6 times, there will be an error slightly less than 30%, right? So there will be a big error when we perform this, right? So that's why we don't do a multiple number of t-tests just to finalize whether groups are different or not. So that's why the technique is that is known as ANOVA. Okay, so so this is being expressed here also as you look for. This is ANOVA that we have discussed. The total sum of square is being divided into two parts between group sum of square and within group sum of square. Right? So this I have explained. In the same way, mean sum of square is sum of square divided by degrees of freedom. And this is a test statistic, which is also known as variance ratio distribution of F statistic that follows this much of the degrees of freedom. Right? So we will be doing this. Right? But before moving forward, just a moment. So now we will be examining this with the hypothesis H naught as mu n equals to mu e. E is the Eastern is equal to mu W is equal to mu S. And H1 is at least 1 mu I is different from others. Now, how we do, we go for the significance F. Significance F is something. Suppose this is less than 0.05. If this is greater than 0.05, we are not rejecting the, so we simply say that there is no significant difference. But if this value is less than 0.05, that is the level of significance. So we would reject H naught. So reject H naught, obviously put a question that uh, that how many mu i's are different. So obviously the question arises, how many mu i's are different from others? Okay. So the question arises whether one is different or all are different, right? So for that, we perform post hoc analysis, which is in the form of multiple comparison. Okay. So first we decide through the F value whether we are rejecting or not rejecting. And if the H naught is rejected, then we are interested to know that which one is different. So for that, we will be going to do post hoc analysis, which is in the form of multiple comparison among different groups, right? So now we will be running the analysis and later on, we will be discussing the output. So this is the data set. We go to analyze, then we go to compare mean because this is an parametric test. And in the compare mean, we have one-way ANOVA. So this is a dialog box. Right? Just for the demonstration purpose, I am selecting Q3 cell. You people can have um, some other cell like Q1, Q2, and so on. And for the factors, we will be selecting location, and this location is being entered into the factor. Okay. Then we go to the post hoc as we have discussed. This post hoc is in the form of multiple comparison and it holds meaning if H naught is rejected. So now this is just an extension of the t-test. So as we have discussed that there may be variance, there may be same variance or there may not be same variance. So we will be taking an appropriate test. Suppose we are taking Tukey. Normally we prefer Tukey or Duncan, right? So here we will be taking Tukey highly significant difference test so to perform multiple comparison if variances are equal. And if variances are not equal, then also, then we will take up another test or another appropriate statistics, let it be Tamhane. So we are either interpreting Tukey results or we are interpreting Tamhane based on whether variances are equal or not. So anyway, we are taking that. Then we go to the option. Here we have descriptive statistics. Then we have homogeneity of variance test. Why this is required? Because this will be useful just to test whether we are going for the equal variance or we are going for the unequal variance. Okay. And if you want to plot the graph, you can take mean plots also. Other things we are not including at present. So then we press OK. So this is the output that we are taking. Let me, okay, and this is the output. So we are not discussing these tables. We directly go to the ANOVA table as we have discussed. This is the total sum of square. Total sum of square is 3232.583. It has been classified into two parts. One is between group variation. Between group means between regions variation, between location variation. This is the amount, and this is the within group variation. So it has been divided into two parts. These are the degrees of freedom. Total number of observations are 60. So here the degrees of freedom would be 60 minus 1. Why minus 1? Because here we put the condition that double summation xij minus x double bar would be equals to 0, means the deviation, sum of the deviation from mean would be 0. So that's why we will be having 59. Now we have four groups, four location, but the degrees of freedom would be k minus 1. Why k minus 1? Because the same way the deviation of the mean from the grand mean would be 0. Means summation I varies from 1 to k xi minus x double bar equals to 0. So that's why we will be having 3. And error is being calculated by subtracting. The 59 minus 3 is 56. So if we divide 1182.803 by 3, we will be having mean sum of square or variance as 394.268. In the same way, if we divide 2049.78 by 56, we are getting this value. If you look for these two variation, this is between group variation and this is within group variation. If you look at this, between group variation appears to be much higher, more than 10 times higher as compared to the within group. So we consider the F ratio, which is the ratio of between group variation and the total variation. And accordingly, the F ratio is 10.771. And it's the P value is, this is a P value, just a moment. Okay. This is the P value. And as you look at, since F is very high, so P value is less than 0.05. 0.05 is our default um, level of significance. So we reject H naught. Okay, means all mu i's are not same. Okay? So this result I am writing down uh, on my whiteboard or the PPT, so that you people are having ready-made solution. Okay, so as we look for this part here, we change the color here. The value of F statistics is 10.771 and the P value or significance F is 0.000. This is less than 0.05. It is less than 0.05. So we would be rejecting H naught. Rejecting H naught means we say that all mu i's, that mu n, mu e, mu w, and mu s are same. At least one mu I would be different from each other. So this is the first part. Now question arises whether all northern, eastern, western, and southern outlets are different, or some are same and others are different. So for that, we will be performing post hoc test. As the name suggests, post hoc means it would be only after the rejecting H naught. So it is in the form of multiple comparison. And here there are four groups. One is northern, eastern, western, and southern. Okay. So we will be having 4C2, that is 4 into 3 by 2. Okay. There will be six comparisons. Six comparison would be in the form of northern, eastern. Okay. Right. So One is northern eastern, the another one is northern western, another one is northern southern. Obviously, there is no point of comparing northern with northern. Right? Now, since northern and eastern are compared once and we are applying the t-test and it is symmetrical, so it is no point of going back with having eastern and north and northern. So we will be having eastern and western, then we will be having eastern and southern. Okay, so these two. Lastly, we get a western one. Western one is with the western with southern. So these are the six pairs we are comparing. These are data in the form of six pairs where we are comparing these values with the null hypothesis as mu1 equals to mu2. So this is just an extension of t. Okay. Now for this test, we require two things. One is whether variances are equal, or whether the variances are unequal. Okay, right. So first we have to decide. How we decide? As we have discussed earlier also, we will be performing Leibniz test, and through Leibniz test we will be deciding whether we should go for the equal variance or we should go for the unequal variance. Okay, so first we are going to perform this test. First, I am showing you the results. Then I am coming back to this slide. Okay. So obviously here, this table doesn't mean anything because we have not analyzed the data. After that, we have a table that is known as test of homogeneity of variance. And here, as we have discussed the name, we have Leibniz statistics. And we will be discussing based on mean only. Okay. So here, what is the value? P value is 0.043, which is less than 0.05. So we reject H naught. Reject H naught means variances are not same. Okay, so this is the results from the Leibniz test. It's only provide that which type of post hoc analysis is to be performed. Here I am writing down the results that we have discussed so far. So before moving forward, we will be discussing the Leibniz test. Though this is not the part of the original analysis, but it simply says that which type of test is to be applied, whether we should go for the equal variance or we should go for the unequal variance. Okay? So this test we are going to examine is Leibniz test. Okay? We will be performing the Leibniz test, right? So here the hypothesis is groups have equal variances. Okay, and H1 is groups or samples have unequal variances. Okay. So here, as we look for the statistics, right? Here the p-value or the significance or the p-value, this p-value is 0.043, which is less than 0.05. So we would be rejecting H naught. Rejecting H naught means groups or samples have unequal variances. Since group of samples have unequal variances, so for post hoc, we should we should consider the case where variances are unequal, right? So for post hoc comparison, we should look for unequal variances case or Tamhane. Tamhane statistics we are going to discuss. Right. So now we will be doing this. Okay, I will be showing you the results. So this is the multiple comparison table. Here the groups are being compared like northern with eastern, northern with western, northern with southern, and so on. These are the p-values. Right? Earlier we have Tukey highly significant difference test. This is to be used when variances are equal, right? And the parallel test is the Tamane, which is for unequal variances case. So either we are interpreting Tukey or we are interpreting Tamane as the situation may be. Now here we will be interpreting Tamane. And remember here, we would be interpreting the situation. Just a moment, right? So this is the situation that we are going to discuss, right? These are the results. These are the p-values, right? For the different tests, a different comparison that is being done for the two groups. This we are going to interpret. So now, okay, you people can have a screenshot of this so that we will be interpreting that on the table, right? Now, now we are discussing these results, and so we are discussing the Tamhane test and with the hypothesis as mu1 equals to mu2. So here the groups that are to be compared is northern with eastern. Then we have northern with western. Then we have northern with southern. Then we have eastern with western. Then we have eastern with southern. Because once we compare northern with eastern, there is no point of comparing eastern with northern. Right? It is the t-test being a symmetrical test, so it doesn't matter whether you compare 1 and 2 or you compare 2 and 1. And the last one is western with southern. Right? So these are the 6 comparisons that we are going to do. And I'm just writing down the p-values as per the lemma. These are the p-values or the significance that I am writing down. The first p-value is 0.044. Next is 0.014. For southern, we will be having 0.00. And for eastern and western, we have 0.979. And for eastern and southern, we are having 0.012. And for western and southern, we will be having 0.033. So these are the values we are writing down. Now, as we look, this value is less than 0.05. So we would be rejecting, right? H naught. Rejecting H naught simply means eastern northern cell is not equals to eastern cell. Then when we compare northern with the western, the p-value is 0.014, which is less than 0.05. So we are again rejecting H naught, this H naught. Okay. So the two groups sales are not same. So northern is not equals to western. Then if we compare northern with southern, again this p-value is less than 0.05. So we would be rejecting H naught, means northern sale is not equal to the southern sale. So as we look these results, as northern is different from eastern, northern is different from western, northern is different from southern. So we can say that northern is standing separately. Now, if we compare eastern with western, this p-value is 0.979, which is greater than 0.05. That's the level of significance. So we do not reject H naught. Means there is insignificant difference between eastern cell and the western cell. So these results are approximately same. So we say that there is insignificant difference or they are significantly same. So eastern cells is equals to western cell. Now after that, when we compare eastern with southern, this p-value is 0.012, which is less than 0.05. So we reject H naught. Reject H naught means eastern is not equals to the southern. They are different. Lastly, for western and southern, the p-value is 0.033, which is again less than 0.05. So we would be rejecting H naught, means western is not equals to the southern. Okay, so these are the results. Now we will be um, discussing these results. So have a broad view. First, we compare the northern. Northern is different from eastern, northern is different from western, northern is different from southern. So northern is standing apart, standing separately. Means this is not equals to the anyone. Now we come to the eastern. Now eastern is different from northern, eastern is different from southern, but eastern and western are same. So it means eastern and western are same. They are on the same pedestal, but different from others. Others means from northern as well as from southern. Right? This is both for eastern and western. Now for the next one. Southern is different from northern, southern is different from eastern and western. So we can say that southern sales is standing separately. Means it is different from all other. So we say that for these five groups, these five locations, we have three blocks. One is northern separately, another is southern separately, and the next one is northern and eastern on the same platform. Now, for the hierarchy of these cells, we are going back to the results and we are discussing this part that where we are having sample means, right? So these are the sampling means, that is the northern 70.64, eastern 62, western 60, and southern 53. Let us note down this value on our whiteboard. So here, let me use some other ink. So the sample values are northern sales are 70.64 thousand, eastern sales are 62.00 thousand, western sales are average quarterly sale is 60.74, and the southern sales are 53.80. Now, if we combine these two results, so what is the final results? Number one, since northern is standing separately and northern is having the highest value. So at the first position, we have the northern region. So northern region is leading in the third quarter. It is having the highest share. Now we come to the second position. In the second position, as per this hierarchy, eastern regions come. But we have just examined that there is insignificant difference between eastern region and the western region, right? So we say that this difference is insignificant, that is 62.00 and 60.74 is the insignificant difference. So at the second position, we have eastern region as well as southern region. Okay. And at the third position, as we have discussed, that sorry. At the second position, we have eastern and western. We have eastern and western. And at the third position, since southern is standing separately and it is having the lowest value. So at the third position, this is known as southern. Right? So this is the hierarchy. Right? So this is all about analysis of variance one way. Remember why one way? Because we have classified the cell, we have divided the cell as per one factor only. And here the factor is the location. If we include some more factors like something else, then that is known as two-way ANOVA and so on. So this is all about one-way ANOVA. Thank you.